Hi. So this is a machine learning project where we will be building a model for prediction of selling price of used cars. So let's move forward and see what is all included in this project. So what are we doing? Now we have a dataset that contains information about used cars. It states out some of the characteristics of the car and the parameters on which one can state the price of that car. Now we will be using this dataset to predict the selling price of cars, or I would say used cars. So details of the project. Now the project is actually divided into three parts. The first part is building a machine learning model. So we will be building a machine learning model that is a random forest regressor model to predict the selling price of the car. Now next is we will be building a web app on Django to mount this prediction model. And lastly, we will be deploying the Django project on Heroku through GitHub. So the machine learning model. We start off with building a machine learning model and we use a random forest regressor model and train that model using the car selling data points. One thing to note here is that we will require more feature building and extraction than exploratory analysis, which will be clear in the upcoming videos. So the data set is in such a way that you first have to extract data from the data points and only then can you work upon or do exploratory analysis to understand more about the data. So the next or the second part will be Django web app. So this is the second part of the course or the project where we will build the web application using the framework Django. We will mount the model we have built in the previous part on the Django project here. Last is deploying on Heroku. So this is the last part of the course where we will deploy the Django application on Heroku using the connections to GitHub. So now let's move forward and work upon the first part of this project where we will be building a machine learning model. So this is the first part of the project where we will be building a machine learning model. Now as you can see, the first code block here is to mount the drive folder onto this collab notebook, meaning now we can access the files stored in our drive folders from this collab notebook. And you will see why we have done this in the third block that is here. So next you can see that I am importing the necessary libraries for exploratory analysis and feature engineering. The first library you can see is the NumPy library. It is a library consisting of multi-dimensional array objects and a collection of routines for processing those arrays. Using NumPy, mathematical and logical operations on arrays can be performed easily and efficiently. Now you might be thinking that there are other data structures also like lists or sets, but as comparison to them, NumPy is much faster, and since the structure of NumPy is having contiguous memory allocations as compared to lists in the list of Python, it is much faster. The next you can see is the pandas library. It is a library for data manipulation and analysis. In particular, it offers data structures and operations for manipulating numerical tables and time series. As you can see, the table formed here for my dataset is through pandas only. Next is the Seaborn library and the Matplot library. Now these are libraries for showing statistical graphics in Python, meaning that we can form graphs or we can form statistical data points using these libraries and understand more about the data. It helps in exploration of your data. Now, as you can see, when we move forward to the third block, I am using the read underscore CSV function, and here I'm giving the link or the path to where the file is present. Now you can see that the file is actually present in my drive in the dataset folder. Okay, so here you can see once I've called this out and using the head function which displays the first 10 as I've given the parameter. So the first 10 data points from my dataset. So you can see the first 10 data points are present here, and you can see the name of the car, the year it was manufactured, selling price at that time, kilometer driven, fuel, it is a diesel or a petrol, there's LPG and CNG also, and then the seller type, transmission, owner, first owner, second owner, third owner, and so on. Mileage, engine, max power is given in by horsepower, and torque, then the number of seats. So from this data set, what we are predicting is the selling price. Now, even at just one glance, you can see that there are columns like mileage, engine, max power, torque that have numerical values but are actually a string data type. You can see there is a numerical value, but it is in addition to kmpl, that is given the mileage per liter. So here you will have to anyhow remove the string part so that you can convert the data into numerical data that can be input into the machine learning model later on. And that is why I had said that we will be needing much more feature engineering and feature extraction as compared to exploratory analysis. Moving forward, using the shape function, you can, or the shape parameter, I would say that there are 8128 data points with 13 columns, one being our target variable or the column that we are predicting. The next is using the isNull function and the sum function. So what does this provide me? Basically, isNull function is a function that tells you how many null values are present in each of the columns in my data set. And the sum is actually taking the sum of or the count of all the null values present in each of the columns for my data set. And as you can see, the name has 0 null values, year has 0 null values, similarly till owner. But when we come to mileage, engine, max power, all of these have 221 null values. So now we have 8,000, more than 8,000 data points from which 221 have null values. Now what you can do is two things. These are basic things. There are even more complex things you can do for removing null values or imputing null values. But the basic things you can do is that first you can directly remove all the null values present or you can fill them. Now since 221 or 222 is very less as compared to 8,000, thus I'm just removing the null values and I'm removing using the drop NA function. Now it takes a parameter which is how and the value present is any. This basically tells the drop NA function that remove any row in which you find a null value. So even if a row has only one null value present for 12 columns, then it will remove that row. If there is more than one null value in just one row, it will also remove that row. So after that, you can see that the shape is now giving me 7,906 data points. So it has reduced, or I would say it has subtracted all of these rows which had null values present in them. Next you can see is that I am importing a library called Ray. So let's talk about regular expressions now, also often called regex. They are a sequence of characters used to check whether a pattern exists in a given text or not. Ray is a Python library that supports regular expressions. Now, as you can see, there is a string that has 190 nanometer at the rate 2000 RPM. So if you can remember, we have a column that is torque. And as you can see, I have just taken the first value from the first data point. Okay, so it has a 190 nanometer at the rate 2000 RPM that is given as torque. Now what I have done is taken this 2000 RPM as my value for torque. Now one thing to understand is that having more revolutions per minute RPM doesn't mean that the car has more torque. It depends both on the this value present here, and the RPM here. But I've just taken the RPM value here because extracting the 190 nanometer value was hard and also very time consuming. But if somebody wants, they can try out to extract this information also, and they can do that by maybe following me or implementing some of the functions that I haven't right now. So what I have done to get this 2000 value, the first thing that you can see is that I'm using a replace function to remove punctuations, or I would say full stop, from this. The next thing you can see is that I'm again using the replace function to remove comma from this string. So what this function does is that if it recognizes that there is a comma in my string, then it will replace this comma with an empty string part. So this 2 comma triple zero just becomes 2 triple zero, that is 2000. And the last thing that I'm doing is using a list comprehension, and with that using the ray library, sorry, and the function find all with a parameter slash d plus. So what does this mean? This is basically telling you that using the function find all the numerical values in the string. Meaning, if I'm using this as my parameter, it will give me the value 190 and 2000, because both of these are numerical values. Though it is in the string format, it will still give me the values. And what I'm doing is, before I'm just storing it into my list, I'm converting it into the integer format. And as you can see, A is the list having 190 and 2000 as the values. So I was successfully able to get both 190 and 2000. Okay, but this might seem easy, but we have to do this for each and every data point for the column torque here. And even if you can see here, in some of the cases, you can see that there is a 190 nanometer parameter given, but at some places there's no parameter given. So you can see that you don't know the unit for this value, so you can't directly get or compare both of these values here. And you can see the same is here, there's no unit given. Even the units for this and this is different, and you can see that there is a range given here, not a specific value as compared to here. So in that matter, this column, I would say, is not really a good data set or data point. But since we have what we have, I've just taken the max value from all the integers that I get, and that you can see here. So what I've done is I've created a function that extracts the RPM as the name suggests, and then you can see Again, I'm doing the same thing. I'm removing the full stop, then the comma, then I'm getting all the numerical values that I can get from my string, but I'm only appending the max value from that. Meaning, if I have a string like this and I get a value of 190 and 2000 in my list, I'm only appending the 2000 value to my final list. Okay, so this is the final list that I'm going to use to create a new column, as you will see below. What I have not told you about is the function toList. Again, as the name suggests, what it does is it takes a series, panda series, and converts it into a string. Sorry, list. Sorry. It converts it into a list. And that list I'm storing in torque list. Now, as you can see, I have now called out the function, and this was my initial list that had the values. See, you can see the strings here, and this is my final list that has the values of RPM. So for the first value, it has taken 2000. For the second value, it has taken 2500. As I told you, I'm taking the max value here. Now again, I've just created a new column with that is torque RPM, as you can see here. Okay, so with this, I was able to tackle one of the columns which had initially string values but was storing numerical type data type. Again, I would be doing the same for max power, for engine, for mileage. And this is what you can see for the mileage column. So again, I have used the toList to extract or to store the data points inside a list, that is mil list. Next, I have again instantiated a new list that I'm going to use later on to build a new column. Again, I have used or defined a new function, and inside this function now, the though the working is similar, we are actually using a different type of method to extract the data. Now you can see that in the mileage, there is no multiple numerical values, just one numerical value with a unit given. So what I'm doing is taking out the numerical value, removing the string part, and then storing that numerical value into the new list that I've created. So what it is happening is that it is using the split function again on strings, and it is splitting on the basis of space. Meaning, here you can see that there's a 23.4, and then there's a space, and then there's kilometer per liter. So that space is actually splitting, and this whole value or this whole string converts into two strings, one having 23.4 and the other having kilometer per liter. Okay, so once this has happened, what I'm doing is using the conversion float and then the value s for converting the string numerical data to float value. And as you can see, I've used exception handling here, and I will tell you what this is helping me in. See, two values were extracted. One was numerical, for example, let's say 23.4, and next was kilometer per liter, kmpl. So if I am converting 23.4 from string to float, this would give me no problem. But if I am converting kilometer, kmpl, into float, then this will raise an error. Now if it raises an error, then it would get into the except block, and except block has a pass function, not a function keyword, so nothing will happen and the loop will run for the next iteration. This means that I am able to extract the numerical value easily and simply ignore or remove the string type, that was kilometer per liter. And again you can see from my 23.4 kmpl, I am directly able to get 23.4, my float values. Did the same, I got a new column which has the mileage in numbers. Now this is going to be repeated for engine also. Okay, now here you can also see that 1248cc is now just converted into a float value of 1248. Again, a new column was created, and as you can see, even here I was using the split function, okay, and using the try and except error handling, I was able to get only the numerical value from my string object. Again, I have just created a new column, okay, a new column that is engine CC with the float value types. Similarly to max power also, now the max power has 74 bhp, so I just have to remove bhp and get a 74 or 103.52 float value types. So I did the same for that. Now once I've extracted all the information that I wanted, I'm removing the mileage, engine, max power and torque columns, as now I'm able to get the data that I wanted also in the format that I wanted. So now I would be moving on to the second part of this first part, where we will be building a machine learning model. Now where we will be doing a simple exploratory analysis to understand more about the data. So continuing from before, we have a new function that is describe function. Using on the pandas data frame object, that is cars new, we can see that it has given me some statistical information about my data set. It has given me the count, meaning the number of data points present, the mean for each of the columns, the standard deviation, the minimum value, 25th percentile, 50th percentile, 75th percentile, and the max value for each of the columns having numerical data type or data points. So you can see here that the selling price, the kilometer driven, seats. So the max seats are 14. I know, like there's a car that has 14 seats. Well, it won't be even called a car, but yeah. And the torque, having the max torque of this, okay, this value. I don't think there's a value for torque that is this high. So from this you can even see that there is some outliers present in your data also, because even till 75th percentile the values were near 4000, which is again a lot. I would say for the revolution per minute for a car it is a lot, but it has even gone more than 10 times for the max value, which again tells you that there is an outlier present in your data set. For the column torque RPM, for the mileage there is 42, which I can still say is believable. And then engine, again this is this is a high value, and max power I can, yeah, it is normal. So you can see that the ranges for our columns are all over the places. As you can see, goes to the power of 7, while this is only power of 3, this is power of 2, power of 1, so small, right? So we might have to normalize some of the columns or standardize the data set. Again, it depends on the precision you want your column, or sorry, you want your model to bring forward. Because as you can see later on, while I'm training and testing, I was getting a really high accuracy. So I didn't normalize the dataset as such. Next, you can see I'm using the SNS, that is Seaborn library, to build myself a graph that depicts the correlation for each of the columns with other columns present in my dataset. Now remember, this only is applicable for numerical columns in my dataset, not string ones. and you can see that the year with year gives me a correlation of 1. Now, even if you don't understand what correlation is, from this you might have been able to understand or guess a little about what correlation brings to the table. So this gives you the relatedness of one column with another. Now there can be a positive relatedness, a negative, or a neutral one. Neutral is basically giving a value of 0. Positive goes closer to 1. Negative goes closer to -1. And the value stays between -1 and 1, both included. Now as you can see, the values that I would say are close are values of 0.75 and 0.7, meaning selling price is very much correlated to max power. So you can see that if a van max power is high, selling price is also high because there is a positive correlation between these two columns. Again, as you can see, engine CC has a high correlation with max power. Now, since there's only 12, 13 columns present in my data set, we don't need to remove any column because the dimensionality is very less and the model will be able to train pretty easily with less computational expensiveness and less time frame also. But if there was a large number of columns present, or I would say the dimensionality was very high, we can use this plot, this SNS plot, to remove some of the columns that are highly correlated because they would be providing the same type of information to the model. And that is one of the reasons why I have built this graph so that we can understood or we can understand how or what columns are similar to each other and not providing much information to the model. Next, we go and find categorical data types. Now, categorical data types are, like treasure troves for models because they have hidden information if extracted, can easily build, help in building a more robust and highly accurate model. So you can see that a fuel column was actually a categorical data type because it has 4 categories: diesel, petrol, CNG and LPG. I'm using the function value count, which gives you the value of unique data points inside a column and the number of times each has occurred. Similarly, I'm doing this for seller type, transmission, owner. So all of these columns have categorical data and you can see for each of the categories how many times they have occurred. Now I'm converting the categorical data to integer format so that I can feed that into my model. Now I've used actually defined a function that is ref1 where if the value is manual I would return a 1, or if a value is auto I would return a 0. You can see there's an automatic or a manual category inside transmission. So in transmission, I'm using the map function, which takes a parameter of another function and then uses that function on each of the data point inside that column. Next, I'm doing the same for my seller type, where if X is individual, I would return 1. If it is a dealer, then 0. And if it is a trust mark dealer, then -1. Similarly for the fuel, and yeah, I would be coming on to this part a little later on. First, I would like to show you what I have actually created. And as you can see here, this seller type now has values of -1, -1, -1. Okay, it is only showing -1, but the values are here -1, 1 and 0 rather than the individual dealer and trust mark dealer. Again, you can see the transmission again has converted from string to integer data type having values 1 and 0. Similarly for fuel. Now let's talk about the getDummies function. Now getDummies function is basically extracting your data, again categorical data, and creating new columns. Right now we were just manipulating, or I would say updating the existing columns using the map function and creating our own reference functions. But this getDummies, this will create new columns for you. As you can see, the owner had some of the values or categories, that was first, second, third, fourth, and test drive car. So you can see new columns were created for the owner column, and the new columns are named first owner, fourth and above owner, second owner, and so on. So what are we actually inputting into all of these columns? You can see that for the first data point, a value of 1 is present for first column and the rest are zeros. What does this mean? It means that the first data point corresponds to first owner. And if you go back and see, yeah, you can see that the owner is the first owner and in the second it was second owner. So going back, yeah, so you can see there's a 1 for first owner and in the second data point there's a 1 for second owner, right? So in this way we were able to extract the information and also create some new columns regarding the values for my owner column that I had. So now I'm just getting myself the target variable and dropping the columns that are not required now. Next, I'm importing all the libraries necessary for model building and checking the accuracy for that model. Now, as you can see, I have only taken the first 3000 data points, not the whole 7900 data points, because there are two reasons. One, it takes more time to train, and the second, when we are actually deploying our project on Heroku, the file that is created for the weights of this model is too large and Heroku is not able to store that file. That's why I've shortened or removed some of the data points so that I'm able to build a smaller model that can be stored by the Heroku server later on. Okay, so taking the first 3000 data points, building my random forest regressor model or instantiating it, having the estimators as 3300 and random state as 42, meaning that data points will be shuffled, and job meaning that all the processors will work in training the models. Now using the function fit, I'm training the data or fitting the data on training data points. Okay, and then I'm using the predict function that I will be using later on actually when we are working on the Django model, or I would say the Django application. Then I'm checking the accuracy, and as you can see, there's a 99.18 percentile accuracy for my training. And if we go forward and check the accuracy for our testing dataset, it still gives me a 97.06 percentile, which is, yeah, very high and good. So we can use this model. And here, as I just told you before, we even haven't, standardized the dataset. If we had done that, maybe the accuracy would have also increased much more. So for as comparison, let me show you a linear regression model. And if I am training and testing it, I'm getting an accuracy of 69 percentile for training and 67 percentile for testing. So in comparison, the random forest is giving me a much higher accuracy. Thus, I'm actually storing that model using the pickle library. Okay, and here I have given the model that I want to save and the place that I want to save it at. So in my data set, there is another folder that is models, and there I'm storing the car selling.pickle file, which I would use later on to predict when we are completing our Django application web using that Django framework. So with this, we come to the end of the first part, that is building our building our machine learning model, and we move forward to the second part, that is building our web app using the Django framework. Hi. So this is the second part of the project where we will be building a Django project or application using the Django framework. So Django is a Python-based free and open source web framework that allows the model template views architectural system or pattern. Now, what is a model template views architecture is what I'm going to show you and make you understand in the upcoming part. Okay. And so basically Django is a web framework that has a lot of sets of components that would help you to develop websites faster and easier. In comparison to some other frameworks, Django provides you with multiple features that are preset for you, and what you can do is just merely update it or maybe add on to it. You don't have to build everything from scratch, which is one thing that I like about Django. Now, before you actually start working on Django, there are some things that you have to notice and understand so that when we are actually working on Django, it won't create a problem or confusion for you. So while I have done some of the things, still I would reiterate them for you so that you might be able to understand how and where I started this web application from and how did I update it or maybe add on to it. Okay. So first you have to create a project directory. Okay. It could be any directory named whatever you want it to. But what the main thing about that directory will be is that you will be building an environment that will be stored in that directory. Now, what do you mean by environment? Environment is basically a visual space that has all the packages dependencies stored in it so that it doesn't conflict with your global packages that Python gives you. Okay, so it might happen that only for one project you want some of the libraries. So rather than installing them and increasing the size of the global package space, you can just build an environment, download or install those specific libraries in that environment, and use the environment, not the whole of the global space. Now, to build an environment, if you're using PyCharm like me, it is very easy. First, you just have to go to Files, and in that you have to go to Settings, and once setting opens, you have to go to the project, and in that you have to go to the project interpreter, and in the interpreter you can see there's a project interpreter and it is already having an virtual environment. Now if you don't have a virtual environment, you can just click on the settings button, then click on add, and there's a pop-up that tells you that the new environment will be built and the location and the base interpreter, meaning what version of Python you want to use for this environment. So since I've already done that, it is already telling me that environment location directory is not empty because there is already an environment present for me. Once you do that, you can install all the packages, which I will tell you how to. You don't have to see each and one and manually install each and every one of them. There's a very simple and cute code that you can just type in, and all the packages and dependencies will be installed instantaneously. So once you have built an environment, the next thing you have to do is, since you are already going to use this code, you don't have to create another one. But I will tell you how I created all of this code. It is not written by me, though some part was modified, some part was add on. But the basic structure was that once I installed Django, I used this command, Django admin start project, and then the name of the project, which I had as my site. Okay, So once I did that, this project folder was created, and inside that, this my site was created. Okay, so once I go inside my site directory in the terminal, I type on python manage.py start app, name of the app, which was polls. So this app was created. As you can see, this directory is storing the settings WSGI files for the Django project, which are the essential files required to handle and authenticate, and many other features that are required are actually set on inside the settings files and through the VSGI file. The next that you see is the post, that is called an app, and in the apps you can see there is a view file, view python file, where major backend work is to be done. Okay, which I'm going to iterate also. So yeah, so this is how I created it. You don't have to run all of these code, because directly you're going to use the code that I am going to provide. What you need to understand is that while you might not have to create the code, but you need to understand how the code is working and what is the model template views architecture, that as you can see the views, the templates, and the models. So these are present in your apps, okay, and each has specific roles which are essential for working of a Django project. Now, as I told you, using the pip install -r requirements.txt command, if you run this on your terminal, then all the packages and dependencies that are required by this Django project will be installed in your environment. And if you can see, there's a requirement.txt file here, and you can see that all the packages that are required with their versions also are present here. So next, yeah. So next you can see, so once you have, you know, run the command pip install r requirement.txt, the next command that you should run is the python manage.py migrate. Now this is actually helpful in instantiating the tables that are provided by Django. So as I told you, you don't have to create anything from scratch. Likewise, Django also gives you some preset tables, SQL tables, that are used for maybe authentication, to store on migrations, and to store on static files, actually information over static files, and so. So to instantiate that, you have to run the command python manage.py migrate. So once you run this command, the next thing you have to do is just run python manage.py run server. I'm going to show you uh, what this command does, though from the name itself you might have understood what it would be doing. But first, let's go on to the settings.py file. So as you can see in this file, there's a secret key, debug mode, allowed host, installed apps, middlewares. You can see there's a security middleware, there's a session middleware, there's a CSRF view middleware. So all of these middlewares are something that are already defined by Django and helps us in handling maybe requests, maybe about session, how long it should run, and about the security measures that a website should have. There are even more middlewares, but I don't think explaining them would be something worthwhile, since if you haven't worked in web applications, then all of this is going to be hard to grasp. So it would be better if you yourself search upon it and see what each and every middleware does. That would be much more helpful to you than just a brief explanation from my side. Next, you can see the templates. Okay, and then the, yeah, this is again you can see there's a database dictionary, where you can see that the engine used is SQLite 3, basically telling you that an SQLite 3 is already pre-installed with Django and you can use it inside Django itself. Okay, but if you want to change, you can even change it to Postgres, maybe MySQL, and so on. Next, you can see this. Now, this is a little important for you to understand. It might be new to many people, but yet it is important to understand. Now, you know that websites have front end and back end. Okay, so Django framework is actually to handle the back end side and to serve the front end for files, or I would say HTML, CSS, Java. Okay, so once you have created those static files, as you can see, static includes all of these and more. Okay, so once you have done that, you have to store those and serve those to the Django so that it understands that for each and every function that it is using, which front end is mapped to that function. Okay, and when I say functions, functions are actually defined here, which are like helps in serving those static files. You can see that at the last part, here is a return, render, and index.html. Basically, this function helps in serving this index.html file and helps in returning and manipulating of data whichever is being sent through this HTML file to the backend. Okay, so this is why we have to set up a static URL and static root. So basically static root is set up so that once you're going to upload your files on the server will understand that it has to build a static files folder where all the static files are to be kept. Right now they are not, they are directly kept inside your templates or maybe somewhere else, but once it goes on to the server, all those files are actually taken away from each and every app and is directly stored into a static files folder that is created then and there. So this is the settings.py file that you will find in my site here. Okay, but what is more even more important to understand is what is happening in views. So views.py file is specific to an app. And again, functions created inside that views file is specific to a template. And when I say template, that directly means that an index.html, an HTML file. Okay, an HTML file. Yeah. So what are we doing here? So let's start with the HTML file. Here you can see that this is the HTML file with an internal CSS loaded with so I think it has hanged. Yeah. Okay, so you can see that now I have created the body. Inside there are many div tags and a form having post method, an action is created, and this form is going to take the data from your front end page and then send it to the backend. Okay, so you can see that input, that is name, is taken, year of manufacturing year, kilometer driven, so on and so forth. Information is taken as in the form of a form, and then that information is sent to the backend, and here all of that information is stored. So you can see that from using the request.post, I am having a post request, and if it is a post request, meaning that the form was filled and submitted, then all of the information that was input in the form shall be sent here and stored in these variables. And once I've stored these, I'm going to just create a data frame and store all of that value inside this data frame. Again, just to load that into the model and predict. Now, before loading into the model, we again have to instantiate the model itself that I've stored. So this car selling.pickle file that I stored in the, or I would say that I saved in the last part, is now being used here, And using the pickle.load, I've loaded the model, and then using the predict function of the model, I'm able to predict the value, and then I'm going to return that value to the front end. Okay, so this is what is essentially happening here, where we get the data, we manipulate the data, or we use the data to find an inference. And when we find that inference, we send that inference again to the front end. So this is how the template views is working with each other. Though the main subpart of the architecture was model template views, we won't be using models as we are not storing any data right now. Meaning that the variables that we have already has stored a lot of values or maybe information about the car that we are actually going to predict the selling price for. But as you can see, these variables have values, then these values are stored inside my data frame, and the data frame is used inside the predict function to just predict and get the selling price. But nowhere we have stored any value inside the database or any table. That is why models is not what we are going to use for this project. Lastly, you can see there's a simple helper function. So this helper function was actually built so that I can fill up the first owner, fourth owner, and the owner classes. As you know, I was using the getDummies function, which created some new columns that were actually extracted from one column, that was owner. So to extract that data, I'm using this helper function. Next, as you can see, I was talking about the run server function, and now I'm going to type in that and let you know what that function works, or actually how that function works and what is the output for that. So python manage.py run server. So I think this is going to take a little time because it is going to start a developer's yeah, it is going to start a developer server, and you can see that starting development server at the base URL. So once you click on that, it's going to open up a page, and you can see that there's a form where you can type in all of the data. And I'm going to now fill up the data. So once I click on submit, okay. So yeah, as you can see, the selling price is, oh my god, 50 lakhs. Yeah, sure. So the selling price is this. Now, this is how, once I input all of the information, clicked on submit, my inference, that was prediction of the selling price, was predicted and again sent back to the front end through the context, that was result, that was response. Okay, and now the response is being shown here. So this is how the Python manage.py run server starts a development server from where you can see how your Django project is working or application is working. Okay, one thing that I have not talked about is the URLs. As you could see that it has given you a base URL, okay, or this is a localhost URL, and on that, how did it know that which template is to be loaded and which views.py file is to be used as the backend functions? So you can see there's a urls.py file also. Here we have defined the path. Okay, the path where the views.py's index function will start working. And there's also another urls.py file inside your my site project directory. And here you can see that this is empty, meaning this URL plus empty URL. That is again the same URL. On that, you're going to set the polls.urls, meaning any URL defined here will be appended with this base URL. Now again, there also I have appending a empty string. So on this base URL, it understands that index function has to be run, and then from there it understands that it has to render the index.html page. So that is how from the base URL it is able to understand which template is to be run and accordingly which backend function is to be done. So with this, we have completed the second part, that is working and using the Django framework to build a Django application or a web application. Now we will be moving to the third part, that is deploying this application on Heroku. This is the third part of the project where we will be displaying or deploying our web application on Heroku. But before we start off with Heroku, we have to understand that we have to use some of the files which are like commands for Heroku to understand and implement when the code is loaded onto the server. Okay, so those two files that I'm going to talk about are runtime.txt and prop file. So runtime.txt is basically just telling Heroku which language or base is to be used by the server. As you can see, there is a Python telling you that Python language is to be used and the version of that language. So the next thing that you're going to look at is prop file. And you can see that a gunicorn mysite.wsgi file is written here, meaning that we are going to use the WSGI file with the help of gunicorn, and there's going to be log file present when we are when the server is going to run. So profile is just the mechanism for declaring what commands are to be run by your application in Heroku platform. The commands that are specified in the last part, like the run server or migrate, these commands are actually executed in Heroku server when the code is set up on the server. And these commands are actually run with the help of proc file only. Next, we are going to see that as I talked about, that we are going to deploy the code with the help of connections to GitHub. So the first thing that you have to do is actually upload your code to GitHub. Like I have uploaded my code to GitHub and all of the files and folders are present here. And you can see that there's the environment and it is telling that car selling price new is actually active, meaning that it has been activated onto a platform for deployment and is active right now, meaning that this code is actually being used by a server and that server has already served the files and the web page or the website is working. So once you have uploaded the files and folders, and they should be in the same exact order as you can see here. Okay, so once you have done that, what you can do is go to the Heroku platform. If you haven't made an ID, just create an ID, and after you log in, you would see that the dashboard opens, and for you there won't be any apps present since I've already created two apps. The two apps present here are showcased. Okay, so for you, what you have to do is go to new, click on create new app. Once you click, you have to specify the app name. Once you specify the app name, you can choose the region, though there's only two regions, United States and Europe, whatever floats your boat. And then the next thing you have to do is click on create app. So once you click on create app, the new app formed will be shown here on your dashboard. And if you click on that, some more features would be present, like overview, resource, deploy, metrics, and so on. The first thing that you have to do is go to settings, and inside settings, you have to set your build pack. Now it would be showing a add build pack to you. Once you click on that, it would be asking you to enter the build pack. So click on Python for it. Once you click on Python, you would be seeing a Heroku/Python in the build packs part. Once you have done that, go back to the metrics. So the metrics are not available. Okay, then go to deploy first. So once you go on to the deploy, you would be given deployment method. Now there are three methods for deployment. You're going to choose the GitHub Connect. Once you click on this, what will happen is that it would ask you to log in into your GitHub account. So once you enter your credentials and log in, then it would ask you to connect an app to GitHub, meaning that it would ask one of the repositories to connect with this app so that the code present in that repository can be used by this app. So there would be a search parameter here and then a search button. So you just have to write the name of the repository and search. Then that would show you the repository name and there would be a connect button. Click on connect and then it would show you that connected to my repository by my account. Once this has been done, what you have to do is go to manual deploys, and in manual deploys click on choose a branch to deploy. Now the code that you're going to use, or the finalized code, is what you're going to present in the branch that you are going to use here. Since the finalized code is in the master branch for me, I'm going to choose the master branch and then click on deploy branch. So once this is done, Heroku automatically starts to set your code in the server. Now you can see that it has started to use the build pack, and from the runtime.txt it has understood which Python version is to be used. Then from the requirements, it has now started installing from the requirements.txt file using pip, and once it has done that, it is going to collect all the static files. Okay, and again once it has done that, it is going to compress the files into specific folders on the server, and then it is going to deploy your code or project. And once it has done that, it was going to say that it is launching and taking a little more time. It is going to give you a button, that is view button. Okay, so once you click on that, you would be able to see your website that is hosted on Heroku. So this might take a little time, and yeah, see, the views button is now here and you can click on it. Once you click on it, your page would be loaded, and again you can just type in whatever you want to type, then click on submit, and once you click on submit, the selling price that the model predicted would be shown here. Or as I can just, yeah, I would type my own name. I was manufactured in 2019. Oh my god, I have run a lot of kilometers. Work on petrol, individual, manual. Number of seats, I have 4 number of seats. Cool. Yeah, so once I click on it, yeah, you can see that the selling price is oh my god, 60 lakhs. I'm expensive. Cool. So this is how your website is now hosted on Heroku, and from where we started, just by building a machine learning model, now it is mounted on the Django application and hosted on Heroku. So with this, we have completed the project. I hope you liked it.